Hey, what's going on, guys? It's Nate here from thetechunion.com, bringing you the fourth tutorial in the Java and APCS tutorial series. In this video, we're going to be talking about how to convert numbers that are in base n to numbers that are in base m, or in other words, convert numbers that are in a base other than base 10 and then to another base that isn't base 10. So like I said in the last two videos, we're not really going to be learning anything new in this video. We're just going to be building on what we've already learned. So I just want to go ahead and review those two lessons before we get started into today's video. So we're going to review how to convert numbers that are in base n to base 10 and numbers that are in base 10 to base n. So we're going to do this because they're basically step 1 and step 2 of what we're going to be learning today, so it'll be good to review them. So say we have a number that's in base 4 and that number is 331 and we want to convert it to base 10. Well, let's make our chart like I showed you in the second tutorial. So we got 3, 3, 1, and then we have the place value terms 4 to the 0, 4 to the first, and 4 squared. So 4 squared is 16, 16 times 3 is 48, so 48, and then we have 4 to the first, which is 4 times 3, which is 12 plus 12, and then 4 to the 0 is 1, 1 times 1 is 1, so 48 plus 12 plus 1, and that gives us 61 as an answer. So that number in base 4 is 61 in base 10. And then when we moved on to the third tutorial, we learned how to do the reverse. We learned how to take numbers that are in base 10 and convert them into base 2 using either the mountain division or regular division strategies, remainder division, as I think I called it. So 15 base 10. So let's go ahead and do mountain division. 15 base 10. So and then we divide it. So divided by 2, and then so that gives us 7 with a remainder of 1. So 7 times 2 is 14, plus 1 is 15. And then divide by 2 again, and we get 3, remainder 1. So divide by 2 again. We get 1, remainder 1. And then we divide by 2 again, and we get 0, remainder 1. So 14, 15, 2 times 7, 14 plus 1, 15, 2 times 36, 7, 2 times 1, 3, 2 times, 2 times 0 plus 1. Alright, we're good. We did the division correctly. So we went up the mountain, now we gotta go down the mountain to read our results, and that is the remainders. So this case it doesn't matter because it goes either way, but typically you need to read the opposite way that you went through the division. So this number in base 2, 15 in base 2 in base 10 is 1, 1, 1, 1 base 2. If you want to look back at the other method, you can go ahead and check the previous video, but that's the mountain division. So let's take a look at today's lesson. We're going to be learning how to convert numbers that are not in base 10 to another base that is in base 10. So basically what we're doing is combining the past two tutorials. What we do is convert the number into base 10, and then we convert that number that's in base 10 into the desired base. So we have 0, 0, 1, 1, and then blank space 1, 1, 0, 1, and I did this because dry as a bite just to make it look a little bit neater. We kind of do that with the commas in base 10. Alright, so what we got, let's make our chart again. And let's not worry about the leading zeros, we'll just ignore them for now. So we got 2, 4, 5, 6 digits we care about. So 1, 2, 3, 4, 5, 6. So 1, 1, 1, 1, 0, 1. And then we have 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 to the fourth, and 2 to the fifth. So 32, let me just go ahead and write their values out when they're expanded. So 2 to the fourth is 16 when they're evaluated, I mean. 2 to the third is 8, 2 squared is 4, 2 to the first is 2, and 2 to the 0 is 1. Alright, so 1 times 1 is 1, plus 2 times 0 is 0, so we'll skip that, and then 1 times 4 is 4, 1 times 8 is 8, let me get a bit more room here. So we got 8, and then we got 16, and we got 32. When you're doing base 2, you don't really have to multiply by 1 each time, but that is how it's calculated. You can just think if there's a 1, then you add that place value term. Just be a faster way of doing it. So we add all the place value terms with 1 in them. So we have 1, 4, 8, 16, and 32 with 1s in them. So we find the sum of those numbers. So let's think about this. We got 1 and 4, that's 5. 5 and 8 is 13. 13 and 16 is 29. And then 29 and 32, that would give us 61. Base 10. 61 base 10. So yeah, we got 48, 56, 60, 61. Yep. Alright, we got it. So 61 base 10, and then so now we have that number in base 10. We will go ahead and convert that into the number we want into hexadecimal. So we'll keep dividing by 16. So divide by 16 here. Alright guys, you know what, let's do the different method. Let's do the remainder division. Sorry I said that we weren't going to do that, but why not? We can just go ahead and review that method real quick. So what we do with that method is we find the highest power of 16. So the highest power of 16 less than our base 10 number, pretty much. So we have 16 would be the, oh, that is way too small for recording purposes. So let's change that to that. There we go. Okay, so we have 16. That's the highest power of 16. That is less than 61. The next power of 16 is 256. That's too big. And then we have 16 base 0. So those two pretty much. So with this method, we take our 61 and then we divide it by 16. So 61 divided by 16, that would give us 3. And then the remainder is, so 3 times 16 is 48, so that gives us a remainder of 13. 13, and then we go divide the remainder by the next lowest power. Yeah. So we divide by 1, and then we get 13 divided by 1, we get 13. Remainder 0. So we have 3, and then 13. And how we represent 13 in base 16, remember A equals 10, and B, so B would equal 11, C would equal 12, and D would equal 13. E would equal 14, and F would equal 15, of course. So we have 3D for our answer. So that is pretty much how you convert a number that is in a base other than base 10 to another base that isn't base 10. So what you do is you take that base and then you convert it to base 10, and then you convert that number that is in base 10 and convert it to your desired base. So pretty much combining both of the lessons from the past two videos. Alright, let's go ahead and take a look at the next example, and then we'll do a short quiz, only 2 questions for today. So let's go ahead and do that. Get my eraser up here, okay. Clear this off and then we can continue. Let me pause. Alright, so it's all erased. Let's take a look at the next example. So we have, let's make a chart again. So 177. So 8 to the 0, 8 to the first, and 8 squared. And then if we evaluate those, that gives us 64, 8 and 1. So those are place value terms. So 64 times 1 is 64, plus 7 times 8, that is 56, plus 7 times 1, which is 7. So we go ahead and add those. That gives us 110, 120, 127. If you notice, it's 1 less than a power of 2, so 1 less than 2 to the 7th, which is 128. Okay, moving on. So we got our number in base 10. So now we need to convert that number that is in base 10 to binary. So let's do mountain division again. So move back to the other method we used. So get a bit more space here. So 127 was our results in base 10. There we go. Alright, so 127 base 10, so let's do the mountain division. So divide by 2. Or let's do remainder division instead. Okay, so the powers of the 2 we'll need are 64, 32, 16. Sorry, I'm so indecisive today. Gosh, what is it? Alright, so 64, 32, 16, 8, 4, and 2, and a 1. So those are powers of 2 that we're going to need. 128 is too big. It's greater than 127, so we can't use that. So 127 divided by 64 gives us 1, and that gives us a remainder of 63. 63 divided by 32, that gives us 1 with a remainder of 31. And then 31 divided by 16, it gives us 1 with a remainder of 15. 15 divided by 8, that gives us 1 with a remainder of 7. Hopefully you can see the pattern here. So 7 divided by 4, that gives us it gives us 1 remainder 3. And then so 3 divided by 2, that gives us 1 remainder 1. Voice crack. 1 divided by 1 gives us 1 remainder 0. Okay, so let's collect all our terms. So we got 1, 1, we got 1, so this one, this one, this one, this one, so 7, this one, and this one, and this one, so that is 1, 2, 3, 4, 5, 6, 7, 7 ones. So the answer is, start off with a leading 0, make it look like a byte. 1, 0, 1, 1, 1, 1, 1, 1, 1. And And this represents the 128 bits, so if it was 128, we would only have this filled in, and then the rest would be zeros. Let's straighten up the 0 real quick. There we go. Okay, so that's pretty much how you convert numbers that are in bases other than base 10 to another base that isn't base 10. So, hope you enjoyed the lesson today. Now we got a quiz for you guys, so go ahead and pause the video. I'm going to go ahead and pause the video, and you go ahead and pause the video, and then when we come back, we'll go over the answers together. So, I'll see you then. Alright guys, let's go ahead and look over the answers real quick. So we got 43 base 5, so let's go ahead and make our chart. 43, and then we got, what do we got? We got 5 to the first, and we got 5 to the 0. And then we have those evaluate to 5 and 1. So 5 times 4 plus 3 times 1 is what this is in base 10. So 5 times 4 is 20 plus 3, so 23 base 10. 23 base 10. Alright, so now let's go ahead and do mountain division to find what this is in base 9. So let's divide by 9. So 23 divided by 9, we got 2, remainder of 5. So, and then we divide by 9 again, so 2 divided by 9, that is 0, remainder 2. And then, so we went up, now we gotta go down, so we read it down. And then, oh my gosh, I need water. That was pretty funny. So go up and then we go down, so 2, 5, that's the answer. The remainder is 2, 5. So 43 base 5 is 25 base 9. Alright, so that is the first solution. Second problem solution is second problem is 324. And so let's go ahead and work that out now. Let me go ahead and erase. Alright guys, so I'm done erasing. We can go ahead and make our chart again. So, whoa, way too small. A5, so 2 place value terms. This is hexadecimal, so 16 to the first and 16 to the 0. We evaluate those, we get 16 and 1. So 16, and then A refers to the value 10, so 16 times 10, almost would extract again. 16 times 10 plus 5 times 1. So 16 times 10 plus 5 times 1. So that gives us 160 plus 5. And that gives us 165 base 10. Then we go ahead and do some mountain division to get us to base 7. Alright, so 165 divided by 7, that gives us 23 with a remainder of 4. And then we divide by 7 again and get 3. And divide by 7 again, we get 0. Oh, whoops, I wasn't doing remainders there. Doing integer division there. So 23 divided by 7, that gives us 3, remainder 2. And then divide by 7 one last time, and we get 0, remainder 3. So make sure that looks right. Yep. Okay, so we went up the mountain, and now we go down, so 324 base 7 when we look at the remainders. So pretty much what we learned today is how to convert numbers that aren't in base 10 to a different base that isn't base 10. And pretty much how you to summarize, we converted that number 2 base 10, and then we convert that base 10 value into the desired base. So I hope you guys enjoyed this tutorial. I hope it was a bit shorter than the other ones. And the next video we're going to be talking about how to do arithmetic with different bases, so that will be kind of interesting. We're going to be talking about addition, subtraction, multiplication, division, and then after that we're going to start programming. Before we start programming, we'll take a look at the topics we're going to cover. So we're mainly going to be, to summarize, we're mainly covering UIL and APCS topics, so that's what you got to look forward to. So thank you guys so much for watching, and I will see you in the next video. Like, comment, subscribe, and bye.